Hello, math learners. We have been talking about Taylor series and the things that we can do with Taylor series. And in this video, we're going to look at integrating a Taylor series. So if you have taken any probability and statistics, then you may have heard of the normal distribution or the Gaussian distribution. And we know that this is a very essential distribution in the world of probability and statistics. So if you are talking about just the general normal with mean mu, variance sigma squared, then here is the PDF. But for this video, we're just going to work with the PDF for a normal with mean 0 and variance 1, just to simplify things a little bit. So our PDF for a normal with mean 0, variance 1 is shown here. We've got 1 over the square root of 2 pi, and then e to the negative x squared over 2. And what you do with a probability density function, or PDF, is you integrate over it to find probabilities. So for example, if you want to know the probability that a random variable x is less than some value b, then you simply integrate over our PDF from negative infinity up to the value b. So simple enough, but of course, at this point, using the calculus techniques that we have, you don't know how to integrate e to the negative x squared over 2. If we were looking for x times e to the negative x squared over 2, in other words, if you were looking to calculate the expected value of x, then you would be able to use substitution. But since we are just looking for calculating a probability, then we would not be able to use substitution. And instead, something that we could do is create a Taylor series for our integrand, and then we could integrate our Taylor series. So that's what we're going to do in this video here. Before we found that the Taylor series for e to the x is 1 plus x squared over 2 plus x cubed over 3 factorial plus x to the 4 over 4 factorial plus and so on. And we learned before that we can create a new Taylor series by substitution. So what we're going to do is we're going to sub in negative x squared over 2 wherever we see x in this expression here. So e to the negative x squared over 2 is equal to 1 plus negative x squared over 2 plus negative x squared over 2 squared. And then we still have the 1/2 from before. Then we've got negative x squared over 2, and we're cubing that. And then we have times 1 over 3 factorial. And then we've got negative x squared over 2 to the 4th power. And we're multiplying that by 1 over 4 factorial, and so on. Okay, so here we've just simply substituted in negative x squared wherever we saw an x in this Taylor series here. Now let's clean that up a little bit. So we have 1 minus x squared over 2 plus. Now here we see that we have a negative squared, so that becomes a positive, and x squared squared is x to the 4th. So we've got x to the 4th times 2 squared times 2. Then our next term here, we have a negative cubed, so that's going to stay negative. So let's just make this a minus sign. And then we have x squared and then cubed. So we've got x to the 6th. And then we're dividing by 2 cubed times 3 factorial. Next term, we've got x to the 8 over 2 to the 4 times 4 factorial, and so on. Okay, so now we have this part of our integrand expressed as a Taylor series right there. We want to have this entire integrand no problem. We can just multiply what we've got here by 1 over the square root of 2 pi. So 1 over the square root of 2 pi e to the negative x squared over 2 is equal to 1 over square root of 2 pi. And we'll just copy everything from up here. So we have 1 minus x squared over 2 plus x to the 4 over 2 squared times 2 minus x to the 6th over 2 cubed times 3 factorial plus x to the 8 over 2 to the 4 times 4 factorial plus dot, dot, dot. Okay, so now we have written our integrand as a Taylor series, and so we can go ahead and actually do this integration. So if we want to know the probability that x is less than some value b, maybe let's call it 0.1, just so that we can have a concrete number to work with. Then we know that we need to integrate over our integrand from negative infinity up to 0.1. And our integrand is 1 over the square root of 2 pi. And then we have 1 minus x squared over 2 plus x to the 4 over 2 squared times 2 minus x to the 6th over 2 cubed times 3 factorial plus x to the 8 over 2 to the 4 times 4 factorial, and so on. All right, so going ahead and doing this integration, we get 1 over the square root of 2 pi. We'll just leave that out in front. X minus x cubed over 2 times 3 plus x to the 5th over 2 squared times 2 times 5 minus x to the 7 over 2 cubed times 3 factorial times 7 plus x to the 9 times 2 to the 4 times 4 factorial times 9, and so on. And then we'll evaluate that at negative infinity and then our value 0.1. Okay, so from here on out, it's just pretty straightforward calculus and limit taking. And so we can see how this all would work. The basic idea here that I wanted to show you was one everyday application for integrating Taylor series, because probability and statistics is pretty important for research in general. And so we can see integrating Taylor series helps us calculate probabilities from a normal distribution. And we can create that Taylor series by using substitution. We're subbing in, we said negative x squared for x. And then we saw that we integrated our resulting Taylor series to calculate probabilities.